This video will talk about the concentration of ions when molecular compounds, or ionic compounds, are dissolved in water. Now we know there are ions in these solutions because these solutions conduct electricity. They are electrolytes. Now these ions are present because we have ionic compounds that can either dissociate into their positive and negative ions, or we have molecular acids that can ionize into different ions. Now, if you remember from previous lessons, ionization means that when a molecular compound, in this case hydrochloric acid, separates or ionizes into positive ions and negative ions. The concentration of these ions we're going to use measured in moles per liter, also known as molarity. Now, what is different about these concentration of ions is that the relative concentration of these ions is totally dependent on the relative number of ions in a compound. So, for example, in sodium chloride, we see that there's one sodium ion and one chloride ion, whereas something in calcium chloride, CaCl2, for every one calcium ion, there are two chloride ions. As we mentioned, the ratio of these ions is totally dependent on the component of the compound. So in hydrochloric acid, we have a 1 to 1 to 1 ratio. So if you have 2.4 moles per liter of hydrochloric acid, you have 2.4 moles per liter of chloride, hydrogen ions, and chloride ions. For a different compound, such as barium hydroxide, BaOH2, if we look at the dissociation equation, we can see that for every one mole of barium hydroxide, there's only 1 mole of barium, but 2 moles of hydroxide ions. Therefore, if the initial concentration of barium hydroxide is 0.12, you have 0.12 moles of barium ions and 0.24 moles per liter of hydroxide ions. That is simply a 1 to 2 ratio between barium hydroxide to hydroxide itself. So let's look at an example. If you dissolve 0.23 moles of aluminum sulfate in 1 liter solution, what is the concentration of each ion? Well, initially we know that if we have 0.23 moles of aluminum sulfate in 1 liter of solution, then the concentration of the compound itself is 0.23 moles per liter. But then we want to find the concentration of each ion. So now we have to look at the dissociation equation, which is already written for us here. I draw your attention to the dissociation ions. There's 1 moles of aluminum sulfate, but there's 2 moles of aluminum ions and 3 moles of sulfate ions. So if we're to do our math, so now we can do our math with our molar ratio. We start with the concentration of our compound, which was 0.23 moles per liter of Al2SO3. Multiply that by our molar ratio, which in this case is 2 aluminum ions versus 1 aluminum sulfate. That will give us 0.46 moles per liter of our aluminum ions. Similarly for sulfate, our molar ratio in this case is 1 to 3. We start with a concentration of aluminum sulfate, 0.23 moles per liter of aluminum sulfate, multiply by 3 moles of sulfate ions for every 1 mole of aluminum sulfate. And remember to cancel out our units or cancel our labels. So then our final answer is 0.69 moles per liter of sulfate ion. Let's do another example. Here we want to find the concentration of fluoride ions in a solution of 4.75 times 10 to the minus 5 moles per liter of calcium fluoride. So step 1 is to do our balanced dissociation equation. So we have 1 mole of calcium fluoride dissociating to 1 mole of calcium ions and 2 moles of fluoride ions. So we start off with, or to determine the concentration of fluoride ions, we write 4.75 times 10 to the minus 5 moles per liter of calcium fluoride, multiplied by that our molar ratio, 2 fluoride, 1 calcium fluoride, and we have 9.50 times 10 to the 5, negative 5, moles per liter of fluoride ions. Let's look at another question. We want to take 75.33 grams of aluminum chloride and dissolve it in 600 ml of solution. And then we want to find the concentration of chloride at the end. First, we need to write out our dissociation equation, which we have right here. Then, we need to find the moles of aluminum chloride, then the concentration of aluminum chloride, and then finally, chloride concentration. So to find moles of aluminum chloride, we need to take the mass of aluminum chloride that we have, 75.33 grams, divide by the molar mass of aluminum chloride, which I've determined before to be 133.33 grams per mole. So then that is equal to 0.565 moles. And we have made 600 milliliters of solution. 600 milliliters is also the same as 0.6 liters. And then if we do the math there, and then we have 0.941 moles per liter. So that's 0.941 moles per liter of aluminum chloride. Now we need to take our molar ratio, which we found to be 1 to 3, and do some more math. So 0.941 moles per liter of aluminum chloride multiplied by 3 moles of chloride for every 1 mole of aluminum chloride. And that gives us a final answer of 2.825 moles per liter of chloride ion. And just to be sure, we see that aluminum chloride, the units for aluminum chloride gets canceled out. Let's do one more example, but this one is sort of in reverse because we're given a concentration of an ion, of nitrate ion, and we know we have a certain volume. We want to find a mass of the solute, in this case it's iron 3 nitrate, that we need to measure in order to get the final concentration of our ion. Before we do that, let's look at our dissociation equation. And then, now we can start. We have to start 0.0173 moles per liter of nitrate. And we have 250 milliliters, or 0.25 liters. If we do the math there, that is going to be 0.0043 moles of nitrate. And then we take our dissociation equation and we look at a stoichiometric ratio of 1 to 3. So we write our 0.0043 moles of nitrate. And now our mole ratio here is 1 mole of iron nitrate for every 3 moles of nitrate. So then the math here works out to be 0.0014 moles of iron nitrate. From our previous slide, we had 0.0014 moles of iron nitrate. We now need to multiply by the molar mass of iron nitrate, which is 241.88 grams per mole. Our units here, moles, cancel, leaving us with 0.3485 grams of iron nitrate. And with proper sig-digs, we run into 0.349 grams. So hopefully you see the importance of using units and canceling them out. And with that, we can determine concentration of different ions, or we are given a concentration of ions and we can determine the mass of solute that we need to use to get that desired concentration.